This lesson will be on 2-8, solving for a specific variable. In example 1, we'll take the equation 3x minus 4y equals 7, and we'll be solving for y. What this means is we want to get this y right here by itself. In order to do that, first, what we'll be doing is moving the 3x over to the opposite side of the equation with the 7. So we're going to move that over by subtracting 3x on both sides. 3x minus 3x crosses off, and we're left with a negative 4y on our left side. On the right side of our equation, we have a 7 and a minus 3x. Now we can put this in whatever order we want, 7 minus 3x or negative 3x plus 7. Now, in order to get the y by itself, we'll have to remove the negative 4. Because the negative 4 and the y are multiplied, we'll be dividing both sides by negative 4. The right side gets divided by negative 4 as well. So y equals 7 minus 3x over negative 4. In example 1a, we'll be solving this equation for n, or we'll be getting this n right here by itself. So first we'll start by moving this 6p to the opposite side by subtracting 6p on both sides. On the left side of our equation we have 15 minus 6p, and on the right side of our equation we're left with 3n. Now if we want to solve for n, we'll undo this multiplication between the 3 and the n by dividing both sides by 3. Therefore, n equals 15 minus 6p over 3. This can also be written as 15 over 3 minus 6p over 3. Because we can divide both of these terms by 3, we'll do this. 15 divided by 3 is 5. 6 divided by 3 is 2, so we're left with 2p. And that still equals n. So our final answer is n equals 5 minus 2p. In example 1b, we'll be taking k minus 2 divided by 5 equals 11j. We'll be solving this for k. So, like a two-step equation, we'll be undoing the division of this 5 first by multiplying by 5 on both sides. On the left side of our equation, we're left with k minus 2. On the right side, we have 11j times 5, or 11 times 5, which is 55j. Now we'll undo the subtraction of the 2 in order to isolate our k. So we'll add 2 to both sides. This will leave us with k equaling 55j plus 2. In example 2, we're given the equation 2m minus t equals sm plus 5. This right here is a 5. So we'll be solving this equation for m. As in solving any equation, if we're solving for m, we need all of our m's on one side. So I'm going to take this sm right here, and I'm going to move it to the left side of my equation with my 2m. I'll do this by subtracting sm on both sides. On the left side, I have 2m minus sm minus t equals 5. Now we need to isolate our m's, so the next thing that we can do is move this t over to the opposite side of the equation in order to isolate the m's. So I'll move this over by adding t to both sides. Now we're left with the equation 2m minus sm equals 5 plus t. In order to solve this equation, we'll have to do the opposite of the distributive property to separate the m's from the 2 and the s. If we take out an m, we'd be left with 2 minus s. M times 2 is 2m. M times negative s would give us that negative sm. So we've basically worked in reverse of the distributive property. And now, in order to isolate our m right here, we'll have to get rid of our parentheses. Because m and the parentheses are multiplied, we'll be dividing both sides by the parentheses. 2 minus s. Our final answer is m equals 5 plus t over 2 minus s. In example 2a, we'll be taking this equation and solving for d. Because we're solving for d, we'll need to move all of our d's to one side of the equation. What I'd like to do is take this 1d and move it over here with the 3d. We'll be doing that by subtracting d, or subtracting 1d, on both sides. So we have 5c equals 2d minus 1. Now, in order to isolate our d, we'll have to move this 1 over to the opposite side. So we'll add 1 to both sides. That way we have 5c plus 1 equals 2d. Now, in order to isolate our d, we'll have to divide both sides by 2 and undo the multiplication between the 2 and the d. Our final answer is that d equals 5c plus 1 over 2. In example 2b, we'll be taking the equation 6q minus 18 equals qr plus s, and we'll be solving for q. In order to do this, the first thing we have to do is take our q's and move them all to one side. We'll do this by subtracting qr on both sides. Once we do this, we have the equation 6q minus qr minus 18 equals s. Now we'll have to isolate our q's by moving the 18 over to the side with the s. We'll do this by adding 18 to both sides. Now we have 6q minus qr equals s plus 18. Now, in a problem like this, we'll use the reverse of the distributive property to separate the q's right there from the 6 and the r. Since they both have a factor of q, we'll take that out and we'll be left with q times 6 minus r. Notice that if you do the distributive property here, you'll have 6q minus qr again. This still equals s plus 18. And now we can separate our parentheses from our q by dividing both sides by the parentheses. This gives us our answer of q equals s plus 18 divided by 6 minus r. In example 3, we're given the equation for circumference being c, or circumference equals 2 times pi times r. Now, if we know circumference and we're missing r, we have to take our equation and manipulate this equation to solve for r. If we wanted to solve for r, we'd have to undo the multiplication between the 2 pi and the r. So if we divide both sides by 2 pi, we'd have c over 2 pi equals r. In example 4, we'll be solving this equation for a. In order to solve or to isolate our a right here, we'll have to undo the multiplication between the 1/2 and the a, and we'll also have to undo the multiplication between the t squared. Let's start with the 1/2. In order to undo the multiplication of 1/2, we'll be multiplying by 2 on both sides. So we'll have 2s equals 2 times 1/2, which is 1, or basically the 1/2 and the 2 cross off, and we're left with a times t squared. Now, to undo the multiplication between the a and the t squared, we'll be dividing both sides by t squared. Our final answer will be that a equals 2s over t squared.